everyone. This video is about the periodic table, a very useful table for chemistry. There's a blank chart right here, and that's because the periodic table has all the known elements. It also has they're numbered in order of their atomic number, or the number of protons they have. Also has their average atomic mass, and it helps us find a lot of stuff. But to use the periodic table, we have to know how to read it. So on the periodic table, there are 18 columns or groups. And these columns or groups are important because all the elements, besides hydrogen, in a column, in the group, have the same chemical properties because they have the same number of valence electrons. And valence electrons are just the electrons on the last orbital shell of an atom. So those are the electrons atoms are going to give away, or that's where extra new electrons are going to be added to when you do chemical bonding and stuff like that. And so the rows on the periodic table are called periods. Those are the 7 rows. The first row is hydrogen and helium, and then you keep going, and then you do not include these last two at the bottom because they came out of right here. That's where they go. That one came from there. And so you take these out just because to make the groups have the same chemical properties and valence electrons, and also to make it fit on a piece of paper. So when you take those out, that helps. Now, something important is this stair-step line. So the stair-step line, you started on the outside of boron, between boron and aluminum, and that separates your metals from your nonmetals. So everything to the left, except for hydrogen, and aluminum is also a metal. Most of the ones touching the stair-step are metalloids, but aluminum is most definitely a metal. And then everything over here and these 2 rows at the bottom, those are all metals. So the left of the periodic table is metals. To the right of the periodic table, including boron, also hydrogen, those are all nonmetals. And then touching the stair-step line, those are metalloids. And they kind of have properties of both metals and nonmetals. And this kind of makes sense when you think about it. If you take, oxygen, that's obviously not a metal, so it is a non-metal. You take zinc, that is a metal. So, and as we see, we have in nature, there's mostly metals. There's not as many non-metals. And so that's kind of how you know where metals, non-metals, stuff like that. Okay, so now moving on, some of the groups on the periodic table have special names. Oops. And so we'll start with the far left group, outlining. And so I'm going to move over here. Those are the alkali metals. So not including hydrogen. Hydrogen acts like a metal, but it's not actually a metal. So the alkali metals are also group 1. And they are the most reactive metal. Oops. Most reactive metals because they have 1 valence electron. So these are all going to form 1 plus cations because they're going to lose that one valence electron to make themselves stable, to have all the rest of their have equal number. And that's why they're so reactive, because they just have one more to lose. So the group next to the group next to the alkali metals, this second group, is the alkali earth metals. And so this is group 2. And these are the second most reactive metals, because they have 2 valence electrons, so they will form 2 plus cations. And so again, just like the alkali metals, they just have 2 left on that last shell, so they're going to get rid of those 2 so they can form, so then they have more protons than electrons, so they'll form cations. So in the middle, groups 12 through 3 through 12, this whole middle section, this is all, and including these rows down here, because remember, they just get pulled out from that middle section. Those are the transition metals. And so the transition metals, that's groups 3 through 12, and they are going to form cations, but of various charges. They're not just going to form one. That's where that ion chart comes into play, and that's why you have the Roman numerals, because for instance, iron will either form a 2+ or a 3+ cation. So you never know. So that's really where that ion chart comes into play, and where you need to know. So you never really know what charge the transition metals are going to find. So this bottom 2 rows are, these rows are called the rare earth metals. And that's because when they were named, the scientists thought there weren't a lot of these elements on Earth. That's not true now, but the name stuck. So these are still part of the transition metals. And so there's the 2 rows. So the top row, this row, that is the lanthanoid, also the lanthanide series, and that's just that top row, and that's because the first element is lanthanoid or something like that. And then that second row, that is the actinoid or actinide series, again named for the first element. That row, there's nothing really special. Actinoid has all those transuranian metals in there. Not all of them, but you know, the start of them. So that's kind of it for the metals. So the next, so boron, carbon, and nitrogen, those groups don't really have a name. There's nothing too exciting about them. But the one with oxygen does, so that's that whole group and that is the chalcogen, the chalcogen family, also known as the oxygen family. That's group 16, and this is the second most reactive non-metals. That's reactive because they have 6 valence electrons, so they're really close to having their full shell filled, and so they're not going to give away any more electrons. They're going to form 2+ anions from gaining 2 more electrons to fill that shell, because once you have that many, you wouldn't want to give it away. That doesn't make sense. You just gain 2 more and you're full. So that's the chalcogen family. The one next to that is the halogen family. That's group 17. And they're the most reactive nonmetals because they have 7 valence electrons. So like we've been stating before, they're pretty close, so they're going to form 1+ anions to get to that 8 to get their full shell. Okay, and then the last group here, I'm running out of colors. This whole group here, that's the noble gases. That's group 18, and they are unreactive because they have 8 valence electrons, except for helium, which has 2. But so their shell is full, and so they don't need to. They aren't going to give away any. These elements rarely bond. If they do, they tend to bond with themselves or other noble gases. So, because once you have everything you need, you're not really going to give it away, right? So that is just a little overview of this crazy colorful periodic table. So that's just a little overview periodic table. I guess the main thing that, if you take nothing else, is that you need to know the valence electrons, because that's going to be very important for bonding. So group 1 has 1 valence electron, group 2 has 2 valence electron. Transition metals are tricky. Group 16 has 6, so they're going to gain 2. Group 17 has 7, they're going to gain 1, and then noble gases have none. So that's it for periodic table. That was a very quick rundown, but I hope to help. Bye.